The following table summarizes the age in months and the maintenance cost Y for a sample of 10 delivery vehicles used by a company. So the age is on the x-axis and the cost on the y-axis. So the first vehicle, A, 63,141. So 63,141, we'd put that about there. And the next one was 1314, and that would go about there. I'm just going to pause recording and plot the rest. We're asked to describe the trend of the graph. So it has a positive correlation. And in terms of the variables, that means as the age increases, let's actually put that way, the maintenance cost also increases. Draw a line of regression through the data. Note it will not necessarily go through 0, 0. We're going to use the CAS again. We talked a lot about it not going through 0, 0 necessarily in the last example, even when that would have made perfect sense. It would make perfect sense here, of course, that a vehicle that is absolutely brand spanking new would not cost anything in maintenance. But, of course, we are beyond the data and we only have so much data. So we just go with the computed line through the points that we have. So I've got my calculator here and I'm just going to bring the actual data back into view. And so if we look at the x's, 63, remember they have to be entered as pairs. So the 141 needs to go next to the 63, but we can just put all the x's in first. We've got 13, then 34, and so on. And I'm just going to pause and do that. So I have all of the data in. And remember, we go to Calc, Regression, Linear. The x's are in list 1, the y's are in list 2, so that's all good. And it tells us y is equal to ax plus b. And it gives us the value of a as 2.374. So we've got 2.374x. And the b is negative 22.935. So negative 22.935, which clearly makes no sense. At least the intercept makes no sense, because a negative maintenance cost would mean that they are paying you. But that is beyond the scope of the data, so we should not worry about that. Here we've got the graph with the scatter plot. So we want to add that on to our scatter diagram. So what I'm going to do is I'm going to compute that. So 2.374 when x is 10 times 10, take away 22.935, gives me 0.8. So 10, 0.8 on this sort of scale is going to be virtually on the axis there. And then let's go to 90 and compute it there. So if I bring the calculator back, all I need to do is go and edit that 10 so that it's now a 90. And that's 190.7. That's off the top of the graph, so I can't really use that point. So let's use 80. See what happens there. 167 really. So 80, 167 is about there. And then we want a line through those 2 points, which it seems that I now have. Use the line of best fit to estimate the maintenance cost for a vehicle aged 85 months. So we actually have the line of best fit. This is just asking us when x is equal to 85. So what we're going to do is get the calculator out and put in x equals 85. And that gives us 178.86. And then for 60 months, we can just do the same thing. Line of best fit was already in the calculator. So just change that 85 to a 60, 119.51. If you're asked to actually use the graph to do that, then you would do that in the normal way. In that for 85, we would go to here. We would measure up to the line. And we'd measure across. And about the best we can do from that is about 175. So let's just call that 175 there, from there. But using the line of best fit is more accurate. But I should point out here that we actually don't have any data greater than 80. So this one here is actually an extrapolation, and so should be considered to be unreliable. Whereas this one was fine, it's well within the data. So that's interpolation and therefore reliable. Explain why it would not be sensible to use the graph to estimate the maintenance cost for a vehicle aged 5 months. So there's 2 things here. First of all, I've actually already marked 5 months on the graph just here. And I've indicated the line goes down here. So we'd end up with a negative maintenance cost, which is obviously has no basis in reality. But the other thing is that we are also extrapolating because we have no data that is less than 10.